Hello everyone. Today the topic that we are going to study is classification of organic compounds. This is in the chapter Some Basic Concepts of Organic Chemistry. Okay, let us begin. So how we can classify the organic compounds, right? So basically they can be classified as, closed ring compounds or, open chain compounds, right? So we'll be seeing the examples of each one of these. And under rings also it can be classified as, homocyclic compounds or heterocyclic. Under that also it can be classified as, alicyclic compounds, or aromatic compounds. And then aromatic are also two types, benzenoid and non-benzenoid compounds, right? Okay, let us see alicyclic or open chain compounds, right? So these are open chain. Can you see ethane, acetaldehyde? It's like an open chain. It is not closed from any ends, right? So if you have ethane, if you have acetaldehyde, right? So basically these are open chain compounds. You can see they're not forming any ring. Here we have isobutane, which is again an open chain compound, and straight chain compounds are also known as aliphatic compounds. So these terms are very important for us to remember, as this chapter is forming a base for you for class 12. It is very important for us to know what is aliphatic compound, what is a ring compound, right? So straight chain compounds are known as aliphatic compounds. Now, what are homocyclic? Homocyclic compounds are, so if you can see here, we are now coming on to the ring compounds, right? Basically alicyclic compounds. So if you could see here, we have carbon, right? All atoms are homo means same, right? These are cyclic. What is a cyclic compound? Cyclic compounds means they're joining, right? Like the ring is joined, right? So these are cyclic compounds. So carbon atoms are there in the ring, right? So it is forming a cyclic compound. Next, we have heterocyclic compound. So if you would see heterocyclic compound here, I have oxygen here, right? So basically hetero means different. Now I have a different atom here. So it is like it is called tetrahydrofuran, right? Next we have sulfur, which is known as thiophene, right? So basically heterocyclic, okay, cyclic means which are closed. Heterocyclic means there is other atom, like there are two different atoms present. Homo means same. Can you see cyclopropane and cyclohexane? The atoms are same, right? Carbon, carbon, carbon. Okay. Sometimes atom other than carbon are also present. We call them heterocyclic. Okay. Next, now there are benzene and other benzene related compounds. So benzenoid compounds, benzenoid aromatic compounds are those that have benzene in them, right? Non-benzenoid means they do not have benzene. See, aniline also has like it is a benzene derivative, right? Phthalein is also a benzene derivative. So those who are benzene derivatives, we call them benzenoid. Now these compounds, they are not benzene, right? See, they're different. So azulene, propylone, they are non-benzenoid compounds. Okay. Next up, we have like heterocyclic aromatic compounds. So if you can see here again, pyridine. So these are classified on the basis of functional group, right? So here you have furan, thiophene, pyridine. Basically, these are aromatic compounds, but heterocyclic. Okay. Let us move forward. So on the basis of functional group also, we can classify the organic compounds. So atoms are a group of atoms if they are joined in a specific manner, which is responsible for the characteristics of chemical properties, that is known as functional group. Like you can see phenol. So on the benzene on top, if I put a OH group, that is a functional group, it completely changes its property to an alcohol, right? So it becomes phenol. Now on top of a benzene, if I add an aldehyde functional group, right? So it becomes benzaldehyde, right? Yeah, if I add COOH functional group, it becomes an acid, carboxylic acid, right? Okay. So now we have started with the homologous series quickly, and then we can start the naming. What is homologous series? Okay, so series that differ by a CH2 unit are called homologous series. So you can see here each unit is differing by a CH2, only by a CH2, right? Right? That is called as a homologous series. It differs by a CH2 only, CH2 group, right? Okay. So here the functional group is same, right? Okay. Alkanes also, if you would see the homologous series of alkanes, can you see they are differing only by a CH2 group? What is the general formula of an alkane? The general formula of an alkane is CnH2n plus 2. Okay, what is an alkane? An alkane is any compound like a hydrocarbon that have just single bond, right? Can you see only single bonds are present? Now, if I add another CH3, It differs by a CH2 unit. If you would see, the difference is 1 carbon and 2 hydrogen everywhere, right? So this is a homologous series, okay? Okay, the members of this series, we call them homologues, right? Now we are moving on to the second topic for today, that is the nomenclature of hydrocarbons, right? I hope you understood about the classification of the organic compounds. Today we are going to study about nomenclature. So let us see the IUPAC system of nomenclature. So IUPAC, the full form of IUPAC is International Union of Pure and Applied Chemistry. So this organization, it has given us certain rules to name these compounds. As you know, there are, so many organic compounds present in the nature, right? It is impossible to, just identify them by their smell or by any other certain characteristics. So we have to give them names, right? And we have to have certain rules for that. So that if suppose I tell you the name, you can also deduce or write its structure. Okay. So in olden times, we used to name compounds, give them a common name. Like for example, ethanoic acid, it was called as acetic acid, right? Formic acid, which is, formic acid is acid that is released by ants string, which is actually methanoic acid, So basically, in the olden times, the names were given based on these characteristics, right? Like formic acid is there, and like tartaric acid is there, which is found in tamarind, right? In lemon, ascorbic acid is found, but these are all the common names. But we have to work on the IUPAC names, right? So let us see the rules. So for example, this is ethane, right? Okay, so if I tell you, okay, if I say ethane, you should be able to draw ethane. That will only happen if we have a set of rules. Okay, so a systematic name of an organic compound is derived by identifying the hydrocarbon and the functional group. Okay, so see, here first step is you need to identify the chain. The chain, that is, there are how many atoms present in the chain? There are 6 hydrogen atoms, right? You also need to see the branching. You need to see the functional group, right? So compound containing only carbon and hydrogen, you call them hydrocarbon. All right. So what is a saturated bond? Saturated bond is a bond where you cannot add any more hydrogen. Like for example, here, you cannot add any more compounds because it is saturated, right? There is no place. Carbon can make only 4 bonds. It has already made 4 bonds, right? Unsaturated means like you have double or triple bond and you can break the bond and add more molecules, right? That is unsaturated. Okay. So in naming, we have to pay attention to the parent chain. We have to pay attention to the branching. We have to pay attention to the functional group. Okay. So let us understand. Like this is the mantra that you need to remember. So we have a secondary prefix, primary prefix, the root word. Suffix is something that comes at the end. Okay. So root word is the number of carbon atom in the parent chain. After that, it is ane, ene, or ine. Ane if it is a single bond. If it is a double bond, you put, if it is an alkene, right? If it is a triple bond, that is alkyne, right? So you need to put ene, ane, or ine. Then if there is any functional group, we add the functional group, add the suffix. Prefix, we add the, prefix, like if it is a cyclo compound, we add that. And if it is substituent with locants, basically the numbers. Please take a screenshot of this. It will help us, to, name our compounds. Let us move forward now. I hope you all have taken a screenshot. Okay. So this is what we need to remember, the number of carbon and the word root. Suppose if there are 2 carbon atoms, the word root is eth. If there are 3, the word root is prop. If there are 4, the word root is but. If there are 5, the word root is pent. Okay. Let us see. So here I have 2 carbon atoms. So my word root becomes eth and it is an alkane. So simply I name it ethane. There is no functional group. There is no cyclo. It is not a cyclo compound or there are no numberings involved here. So it is simply ethane, right? Single bond. So eth plus ane, ethane. Next up I have alkene. So 2 carbon atoms. So the word root is eth because 2 carbon atoms and then it is an alkene. So I'll name it ethene. Simply I'll name it ethene, right? Next up, let us see next. So next I have a triple bond. I have 2 carbon atoms. So I name it eth and I write YNE. So it becomes ethyne. Okay. Easy. Okay. Next, so straight chain hydrocarbons, we have ane attached to it, right? So you can just have a look at this table. Very easy it is. you will understand it, like methane, ethane, propane, or nonane, decane. Decane means there would have to be 10 carbon atoms, okay? And the rest would be hydrogens. So if I would give you like a general formula of alkanes, it is CnH2n plus 2, where, you know, N is the number of carbon atoms, right? Okay. Now let us see nomenclature of branch chain alkanes. So if there's branching present, so first point is you need to find out which is the largest chain, okay? So basically, if I count from the left to right, so 1, 2, 3, 4. If I count from here also, 1, 2, 3, 4. So both ways I am getting the same chain, right? So let us understand. Okay, firstly, so suppose CH3, what is CH3 called? So basically methane, and there is one hydrogen less, so it is called methyl, okay? So all the small carbon chains, they're alkyl groups. So like this would be ethyl, this would be methyl, okay? Now, a small chain of carbon atoms are present. So what should we do, right? So basically methane is known as methyl, ethane, ethyl, propane, propyl, butane, butyl, decane or decyl. Let us see, the alkyl groups are branched, right? So how to name them? Let us see. The longest carbon chain is identified. So see, 5, 6, 7, 8, 9, or it can also be like this. Yes. So I think the first one is the longest chain. So we go with the first one. Okay. Right. Not the second one. It would be wrong because we have to look for the longest chain. Next, the numbering is done in such a way that the branch chains should get a lower number. Okay. So here, if you would number from left to right, see, the branch chain are getting the number 2, 6, 2 and 6, right? 2 and 6. Here the branch chains are getting the number 8 and 4. So which one is better? You tell me which one is better. The first one, right? So branched part, the branch chain should get the lowest number. Okay. Let us move forward. Lowest, this is known as the lowest locant rule. Okay, chalo. So we have this. Let us name this. So what is the word root? Word root is N, non, right? Okay. Okay, so it is like nonane. But I have methyl on the second carbon atom and I have ethyl on the sixth carbon atom, right? So it is 6 ethyl, 6 ethyl. Why did I put ethyl first? Because we go alphabetical order wise. So I know that, you know, it is my word root is nonane, my parent chain, but it is 6 ethyl first and then 2 methyl because E comes before, right? 6 ethyl, 2 methyl, nonane, as it is written over here, 6 ethyl, 2 methyl, nonane. Okay. Let us move forward. Okay. So numbers are separated from the groups by hyphen, which is very, very important. You have to separate the numbers by hyphen. Okay. And there is no gap in between methyl and nonane. There is no gap. Okay. If different alkyl groups are present, they are listed in alphabetical order. Okay. And if two or more identical groups are present, right, then the numbers are separated by commas. Let's see. So see, we have numbered it according to the longest chain and we have given the lowest locant rule as well. Now here we have two methyl groups, right? So how are we going to name it? So we are going to name it 2, 2 dimethyl pentane. Okay, 2, 4, sorry. 2, 4 dimethyl pentane. Okay. Here, what are we going to do? Here we are going to name it 2, 2, 4 trimethyl pentane. Okay, because there are 3 methyl groups. And what are their positions? On the second carbon atom, there are 2, like 2, 2 and 4, right? Okay, 2, 2, 4 trimethyl pentane. Now, can you all try this? Can you all try this? What will we name this? So we will start from here. We are starting because starting from left is giving the lowest locant rule. It is satisfying it. So we can say this is ethyl. So first ethyl and then we have methyl. So we'll say it as 3 ethyl because ethyl will come first. 3 ethyl, 4, 4 dimethyl heptane because 7 carbon atoms, right? Okay. And now if two substituents, you know, if they are found in equatorial position, the lower number is given to the first in the alphabetical listing, right? So if you would see in the both positions, we are getting 3 and 6 on the branch. Here also we are getting 3 and 6 on the branch, right? So the one that has the alphabetical order, ethyl is coming first. So we give ethyl the lowest number. So first one is correct, right? Second one is wrong. You cannot name your compound like this. Okay. The carbon atom of the branch that attaches to the root alkane is numbered 1. Okay. Let us move forward. Okay. So see, so here also, like, this is a branch and this is also a branch. So we need to name this branch separately. So we need to name this branch. So, okay. Let us understand it is 5, 1,2 dimethyl. Okay. Propyl. Okay. Why it is 1,2 dimethyl? So we are starting from here. This is the first carbon atom, right? Okay. So it is 1,2 dimethyl. On both 1 and second carbon atom, you have methyl, right? Propyl, because obviously it is a substituent, right? So it is an alkyl group, propyl, 3-ethyl decane. So again, here we are going like alphabetical order wise. Okay. Okay, so iso and neo prefix are also used to name. So let us see. Iso is when, let us see. So here you can see it is 5 secondary butyl, 4 isopropyl. So this is known as secondary butyl, right? Butyl means 4 carbon atoms. So this carbon atom is a secondary carbon atom. Okay, what is a neo group? This is a neo group. So if you can see here, right? Sorry, neo group is not there here. This is a neo group, right? This is isopropyl group. Isopropyl group. This is isopropyl group. This type of group is known as iso group. Okay, so 5 secondary butyl, 4 isopropyl decane. Okay, so if there happens to be two chains of the same size, then the chain is to be selected which contains more number of side chain. Okay, right? So if you can see, the numbering is done from the end closer to the substituent, right? So it is 5, 2-ethyl butyl, 3,3 dimethyl decane. So just pause the video, try to see, okay, from where should I name? Should I name from here or should I name from here? Right? So we are naming from here, right? Okay. So can you all try to do the solution for this? Again, it is very easy. Just try to do the solution for this. What is this? Okay, just try to name this first. This will be placed in the prefix, right? And your parent chain would be nonane. Okay, just try to do it. Okay, so longest parent chain is nonane, right? And the branch is 2,2 dimethyl propyl, right? So how do we name this? So 1, 2, 3. Right? In the second carbon atom, you have 2 methyl groups. So 2,2 dimethyl propyl is the substituent. Dimethyl propyl. So it will be 2,2 dimethyl propyl 5. It will be 5, 2,2 dimethyl propyl nonane. Right? 5, 2,2 dimethyl propyl nonane. Right? So again, this is like a test which you can just pause the screen, do not see the answer, and check your answer and also see the mistake that you are making, right? So IUPAC naming is actually very interesting and it is very important for class 12th as well. Okay, so just pause the video and try to do this. Okay. So thank you so much. I hope you really understood the rules of the, the IUPAC nomenclature and you were able to understand the classification of the organic compounds. Right? So if you want to study more in detail, practice more in questions, so we can study through Urban Pro, you can get in touch with me through my profile. Thank you so much.